Physiology 230, Chapter 6, Presentation 6, also known as Last Presentation. This will be specific to factors that influence adaptations. So let's get into this. Much like we talked about in another presentation regarding resistance training, we're talking specificity, genetics, sex, age, overtraining, and detraining. This will be about 10 slides. Let's see if we can get through it. With specificity, all training and training outcomes are driven by a specificity in training. If you want certain results, you have to train a certain way. The adaptations that occur are a result of a training stimulus. It's pretty straightforward stuff, and it's in the parlance of like strength and conditioning. Everything we talk about is about specificity and training, and it boils back down to general adaptation syndrome and applying the right training response or the right training stimulus to get the right training response. Now, when it comes to specificity for your general population in terms of fitness and working out and losing weight, etc., it becomes a conversation of, okay, we can do aerobic training, but we can do some cross training to reduce the likelihood of overuse injury. It doesn't have to be running on a treadmill every time they come in. So we can use some other tools within the environment to basically as a means to the end, right? So I will say this, when you start talking about specificity and training, you will see some things where people really overcomplicate a simple process in terms of their specificity and you try to be like too specific. But long story short, it's one of the big stressors that have influenced adaptation. And I hit on it before, if you're trying to have larger cross-sectional area of muscle fiber, then you're trying to really focus on type 2 fibers. Well, aerobic training might not be what you're after. But if you're trying to increase oxidative capacity of blood, the ability to have more blood flow through the system, greater cardiac output, then perhaps now we're talking aerobic training. That's going to be more specific. With genetics, they talk about the genetic factors being approximately 20 to 30% of the differences between individuals in maximal aerobic capacity. And about 50% of the differences of maximal heart rate. I put this in here because I'm almost certain I've seen it before. It's a combination of nature and nurture, right? You have the genetic potential to be predisposed to maybe being more of like a distance runner or more of a thrower, like in track and field. And we've talked about that in terms of different somatotypes. We talked about that in this class. And so to a certain degree, people are born with a theoretical ceiling on human performance, whereas one somatotype might have a higher ceiling in terms of being able to run long distances really fast, whereas other individuals have a theoretical ceiling of human performance in their ability to throw a shot put further than anybody else. In terms of the genetic side with aerobic training, now we're talking about perhaps somebody who has a large VO2 max and they have the ability to really offload a lot of, or load in a lot of oxygen into the blood and being able to offload a lot of CO2. This is somebody who maybe has a theoretical ceiling of performance that's much higher than their peers in distance running and track and field, and they might be exceptional as a runner. The other part of this is the training stimulus. Great, so you have great genetic potential, but you got to work at it, right? And so it really takes into account, you have to have the genetic potential and genetic capacity to have a high ceiling of performance, but there has to be the right training stimulus, that specificity of training that we just talked about, and the person has to be motivated to want to be better. With sex, much like before, like we saw in resistance training, some of the differences are all about absolutes. Men tend to have more muscle mass and less fat than their female counterparts. Women tend to have smaller hearts and lungs and overall smaller blood volume, which makes sense if the person's body is smaller. But when you look at some of the pound for pound comparisons, and it's a little bit difficult when you start talking about sprinting or running, etc., that starts to equalize out a little bit in terms of pound for pound ability. But in terms of absolutes, it's a little different animal just because of the men having a larger amount of muscle to work with and also a larger heart to work with and more blood volume. When we get into age, as we age, our highest levels for VO2 max are about 12 to 15 for females and 17 to 21 for males. This will be over here in the text you can see. And then after this plateau, there's like this gradual decline. But what you see is those who remain active will show a slower decline in VO2 max over time. This is represented by this chart that you find in the book. And what you find is a runner who ran at high intensity will stay elevated, but somebody who is runner at reduced intensity or so forth, they'll still have an elevated ability. But the person who is a runner and stopped running, notice what happens. They drop down pretty precipitously, almost down to the untrained level. Whereas somebody who might just be fitness trained as opposed to being a competitive runner, like green or red or blue, this person who is a runner and stopped training, they actually drop off in terms of their VO2 max pretty noticeably. So it kind of just pays to keep moving. You just got to keep moving. Saying goes, you got to move it or lose it. So with overreaching, you look at training variables and program designs. We talked for program design. We talked a little bit about periodization. You have to manipulate the training variables, and if they are not, or if the training variables are too excessive, the person can no longer adapt. I mean, our bodies are amazing at adapting to stressors that we place on it, but they'll only adapt so far. And depending upon the stressor, they can only adapt so far, or they'll only adapt so far in terms of laziness. Like you got to change the stressor, otherwise our bodies will just become bored with what you're doing. So this process leads to a decline in performance and a number of basically psychological and physiological factors, right? Or symptoms, where people are bored, they're not inspired to train, in some cases they're sore, they can't really push as much weight around as they could, they're running slower than they did. These are all symptoms of having a little bit of too much overload in the process. But I want to point this out because I know you're going to see this too. With aerobic endurance overtraining, that results predominantly from excessive volume, and it's parasympathetic dominant. Whereas anaerobic or resistance style overtraining, that's more sympathetic dominant, primarily results from excessive high intensity overload. So notice the difference there. If you're talking about an overload on the aerobic endurance side, that's going to be a volume overload issue, parasympathetic. And if it's on the strength side or resistance training side, it's going to be more sympathetic dominant, and it's going to be from excessive high intensity overload. I want to point that out, and part of this too is with overreaching, you have to look at this in terms of it's a short-term state where you kind of exceed the capacity of the person without sufficient recuperation. There's many ways you can incorporate in recuperation into the process. But the book does a pretty good here of noting some of the overreaching and overtraining, and they kind of blur the line between overreaching and overtraining, which is okay. I'm not going to stress too much about it. But these are some of the symptoms that you see when a person comes in. It could be just, I don't really care to train, I'm really wiped out. And then it gets more clinical in terms of submaximal heart rate, submaximal plasma lactate. Those are things that you have to actually test for. But sometimes it comes down to the person's affect, right? Their psychological mood. I'm kind of depressed. I got a little anxiety, fatigue, whatever it may be. They're not up for their training session. Those are the things that a coach can key on very early in the process. And a trainer can key on very early, and even a physical therapist very early in terms of seeing what their client's status is when they come in to see them. It's never the same. It's always going to change. So with detraining, it's the discontinuation of training. And once stopped, the body will reverse the process. We work so hard for hypertrophy and have these great adaptations from aerobic and anaerobic training. And what ends up happening is when you stop doing the training, you stop applying a stressor to the human organism, you stop getting a training response, the body will start to naturally just fall back to its homeostasis where it was before. So again, you got to move it or lose it. That's the best way I can say it. All right, guys, moving on to the next module. Have a great one. Bye.